second part of the three-part series on duct construction and SMACNA standards. Our next Zoom seminar will be on June 24th, same time at 10 a.m. We'll be going over rooftop ductwork, casings for large duct, and kitchen grease duct. We'll get you more information out after this program. But I want to welcome you guys and thank you for being here. As the programs committee chair, we thought this was a very worthwhile program. This is something that our industry and our contractors have been asking for. We have two of the top people at SMACNA National doing this for us. And I'd like to welcome Jeff Parks and Eli Howard and do a small introduction for both of them. So Eli Howard has been a great friend for a long time, and he is one of the backbones of SMACNA. He's the executive director of technical services and has been with SMACNA for well over 25 years, I think closer to 30 or maybe even more. He's responsible for all SMACNA technical standards, manuals, and guidelines for the HVAC, industrial, residential, and architectural sheet metal industry. His role has additional responsibility as both a voting member and liaison to other national standard developers in the industry, such as the ICC, the National Fire Protection Association, International Association of Plumbing and Mechanical Officials, and on and on and on. The list goes on. I want to welcome him. Thank you for being here today, Eli, again. You're such a wonderful part of SMACNA. And then we have Jeff Parks as well, who is fantastic and helping us out a lot here in Southern California. Jeff Parks is a senior project manager at SMACNA, and he has over 30 years of experience in the sheet metal industry. His background includes completing a union sheet metal apprenticeship program and working in shop fabrication, CAD, estimating, project management, and senior leadership at a major East Coast sheet metal company. So thank you guys both for being here and sharing all your knowledge with our contractors. I hope you guys enjoy the program. Thank you.
All right. Did you have anything?
I just want to say great. Thanks so much for everybody being here. Just a little add-on piece here. Both Jeff and I were just recently appointed to the Uniform Mechanical Code Committee, which in essence handles the state of California because they usually take the UMC and convert that into what's called a California Mechanical Code. And just to let you know, we're on that committee now as voting members. If you have issues related to what's in the existing mechanical code, let us know because we have to start putting our code change proposals in between now and December 31st to get all of our changes in for the next code cycle. After that, we got to wait another 3 years. So I'll be reminding all the California contractors every time I see them that we're on the committee. If there's things that we need to look at for code changes in the mechanical code or issues you're having problems with, let us know. We can start putting those forth to get those on the docket for the committee to start discussing those the first part of 2027. So I just wanted to add that one point on it. We just got the appointments here a couple of weeks ago.
Perfect.
Yeah.
All right. Well, I'm going to go ahead and get sharing my screen, and we'll get into this second part of 3. So let's bear with me one quick second.
Perfect.
There. Hopefully everything looks good on your all's end. All right. So let's get right into it. Kind of a recap for those that were with us at our last session. We kind of went over rectangular ductwork, exterior, interior reinforcements. For this part, we're going to get into round ductwork, terms and construction options, that using spiral and longitudinal seams. We're also going to get into some flat oval ductwork construction options, both spiral and longitudinal, and then some hanger selections. So jumping right into it. So first part here, we're looking at round duct joints and seams. We're going to check out the transverse joints first. Sorry. There's a little thing in the way of my screen. Got it. All right. So first off, we have our RT1, which is our beaded sleeve joint. A couple things to point out on this one, can be used for longitudinal or spiral seam applications. You want the sleeve to be at least, the same gauge as the ductwork, minimum 4-inch long sleeve. Your attachment or screw requirements, you want to use a uniform intervals of at most 15 inches along the circumference, and then 3 screws minimum on duct diameters 14 inches and less. The next one we're looking at down here is going to be our companion flange, the RT2 or Van Stone flange. This one can also be used on longitudinal or spiral seam applications. And we have a little minimum flange sizes on this detail. So for diameters up to 10-inch, we would require a 1-inch by 1-inch by 10 gauge angle. And then duct diameters, over 14 inches would be 1.5 by 1.5 by 1/8 inch. So these companion flange sizes would not qualify as joint reinforcements, but if you do want your flanges to qualify as a joint reinforcement, we would use table 3-4, which we're going to get into shortly. Next up, we have our RT3 drawband joint. Again, this is a minimum 4-inch drawband. Can be used longitudinal or spiral. And then also the drawband, you want that to be at minimum the same gauge as your ductwork. Next up is the RT4, just below our RT3, the outside sleeve. So this is going to be for longitudinal seam applications only. And then you would follow the seam requirement or screw requirement, for the RT1. Next up, we have our RT5, the crip joint bead option, 1-inch minimum lap, good for longitudinal and spiral. And then again, you're going to follow the RT1 for any screw requirements. And then we have our RT6, the swedge or bell. This is going to be a longitudinal seam application only, and also RT1 for your screw requirements. Here we have our next up would be the slip-on flange. If you recall from our last program, discussing this for rectangular, this is something that you would want to consult the manufacturers for their ratings established by the performance documented to the functional criteria in Chapter 11 of the Duct Standards. This is going to be your AccuFlange, spiral, any proprietary product that may have been reviewed by the SMACNA Testing and Research Institute would be on our website, and then it would be verified as an acceptable alternative to use. Next up, we have our round longitudinal seams. So we kind of looked at the longitudinal or our transverse joints. Here we have a RL1 spiral seam. It can be used up to 10-inch water gauge and is good for positive or negative applications. Any pressures that get any greater than 10-inch water gauge, we want to refer to the round industrial duct construction standard, and also any duct diameter greater than 96 inches would put you in that round industrial as well. Moving on with some more longitudinal seam, we have the RL2, RL3, or lap joints. These can be used on positive or negative 4-inch water gauge applications. It is acceptable to 10-inch water gauge if it's spot welded on 1-inch intervals or tack welded on 3-inch intervals. And then just below that, we have our RL4. This would be the butt weld or lap and seam weld. And this is also good for positive or negative 10-inch water gauge. Next up, we have our RL5. This is our groove seam, our pipe block or flat lock. Also good for positive or negative 10-inch water gauge. And then just below that, we have all of our different snap lock seams, RL6A, B, 7, and 8. So this would be good up to 2-inch water gauge positive or negative 1-inch water gauge applications. Anything above those, you would need to look into some of the other longitudinal seam choices. So I did mention, our round reinforcements a little bit. So in the standard, we have 3 tables, table 3-2, 3-3, and 3-4. 3-2 is going to be the angle ring size. So this is our reinforcement sizing requirements. Table 3-3 would be the ring attachment schedule. So this is going to be your minimum attachment points to the duct wall. And then table 3-4 is going to be any companion flange joint that would be used as a reinforcement and qualify as a joint reinforcement. So taking a look at table 3-2, as you can see, we have A, B, C, D, E, F, G reinforcement classes, starting at 1x1 to 1/8 inch, all the way up to 3x3 by 1/4 inch. And then table 3-3, this is going to be your ring attachment schedules. So this is based off of diameter size range. So 6 and under, 12 to 7 inches, 18 to 13 inches, and so forth. And then the right side of this table is going to give you, your number of attachment points. So if you have 12-inch diameter and you're attaching your angle reinforcements, you would need a minimum of 6 attachment points. And then here we have table 3-4. So this is when companion flanges would qualify as a joint reinforcement. For any other angle or companion flange, we would refer back to figure 3-1. But this is going to be your schedule for that companion flange to qualify as a joint and a joint reinforcement. And the little asterisk, I don't know if you can see my mouse kind of hovering these asterisks. It just, there's a note on this page that indicates that 10 gauge would also, a 10 gauge ring would be acceptable with those sizes versus the 1/8 inch. All right. So round duct, a couple of things to throw out here. High strength to weight ratio, uses the least amount of material to convey air. Fabrication for negative pressure is adequate for equal positive pressure. Fittings with long seam bodies will be fabricated from longitudinal seam gauges. This includes fittings used with spiral seam straight duct. Fittings with spiral seam bodies would follow the same wall thickness, not less than specified for spiral seam straight duct. And we have tables for these gauges, minimum gauges, and that's going to be table 3-5 and 3-10 through 3-13, which we will get into checking some of those tables out a little bit later in the program. And then, oh, sorry, did somebody have a question? Nope. Okay. Thought I heard something. And then finally, ribs and corrugations may add strength to round duct. So we're going to jump into an example here. This first example, we're going to build some positive 10-inch water gauge, 24-inch diameter round, and we're going to use either longitudinal seam or spiral seam for this. And for this one, we would go to table 3-5, and this applies to positive pressures up through 10-inch water gauge. So this is probably one of the easiest duct construction tables to read. You come to table 3-5, check your diameter range. For this one, we have 24-inch diameter. Our longitudinal seam minimum gauge is going to be 24. And then our spiral seam minimum gauge for the same diameter would be minimum 26 gauge. And at these gauges, no other reinforcements will be required. So this is the unreinforced round duct gauge up to 10-inch water gauge.
Yeah, but I'm muted. Oh.
Now you are. All right. So for our solution here, this first example, we would have either 24 gauge longitudinal seam or 26 gauge spiral seam. And again, both of those options would require no additional reinforcement. And our fitting gauges would be 24 gauge for the longitudinal seam. And then if we were using, a spiral seam bodied elbow, you would follow the spiral seam gauge, which would be 26 gauge for that elbow. So next up we have a longitudinal seam round we're going to build. So this is going to be a negative 10-inch water gauge, same diameter. We'll be using, as I mentioned, longitudinal seams. And for this one, we would use table 3-6 through 3-9 in the duct construction standards for negative pressure longitudinal seams. So there's table 3-10 through 3-13 is for spiral. And then negative pressure classes that are covered are negative 2-inch, 4-inch, 6-inch, and 10-inch water gauge. And then, you'll see within the tables, there's multiple solutions available based on your reinforcement spacings. So checking out this table, this is table 3-9. This is the minimum gauge required for longitudinal seam duct under negative pressure. Again, we're looking at 10-inch water gauge for this one. And you can see in the red rectangle I have here, there's many options based on either unstiffed, no reinforcements required, stiffener spacing of 20 foot, 12 foot, 10 foot, 6 foot, all the way down to 5 foot. So if we were looking to use the 5 foot section, something that you can roll within your, roller machine. Sorry, lost my train of thought there. You would build this out of 24 gauge, and then you would need an A class reinforcement at the center of each piece. So that would result, in a stiffener spacing of 5 feet. So now we know, okay, come back to this one, we're using our 5 foot stiffener spacing. We have our minimum gauge, which is 24, and we have to find out now what is the requirement for that A reinforcement. We would go back to table 3-2, check out, that an A reinforcement is going to be a 1 by 1 by 1/8 inch angle. And then now we know what the angle size is. We would jump over to table 3-3, and this is going to give us our ring attachment points. And since we are looking at 24-inch, we would go to the 30 and under. And then it's telling us that we need 12 minimum attachment points for that angle. And then the rings may be attached to the duct wall using screws, rivets, or tack welds. So this is an example of what that solution would look like. What we would do, you can join 2 5 foot sections to make a 10-foot joint. And then, you could use a beaded sleeve because that's good up to 10-inch water gauge. And then you would have your A reinforcement class angles at the midpoint of the 5 foot sections. giving you a 5-foot stiffener spacing for that build. Another option from the same table would be, if we looked at using 12-foot stiffener spacings, this could be made from 2 5-foot sections, taking into account that if you have a 6-foot roll capacity, this would be made out of 20 gauge. And then we could use companion flanges that also act as stiffeners for reinforcements. So what we would do, we would check table 3-4 to see when, what the size requirement is for these companion flanges. And we're looking for an A reinforcement. So table 3-4 for companion flange joints used as reinforcements. Check, based on our duct diameter for this one, which was 24 inches. We would look at our 13 to 25 inch diameter range. And it's saying we would need, the table tells us we need 1.5 by 1.5 by 3/16 angle for that companion flange. So looking at a detail of how this build could possibly go, you have your 2 6-foot sections, and you could join any approved method for negative 10-inch water gauge. This one, you can weld it, you can do beaded sleeve, and so on. And then what we're doing is putting the angle rings as companion flanges on each end, making, a 12-foot section. And that would be our 12-foot stiffener spacing. And again, those rings would be 1.5 by 1.5 by 3/16 rings based off of table 3-4. And then finally, not finally, but a third solution could be, making 16 gauge using the unstiff or no reinforcement required column. You can make 2 5-foot piece sections, shot butt weld, and then no additional stiffeners or reinforcements would be required, at this gauge. And you could also use the companion flanges for field joints that would not require, it would not act as joint reinforcements, but, for ease of field connections. And again, those companion flanges, from figure 3-1, we have the minimum size of 1 by 1 by 10 gauge up to 14-inch diameter. So if we chose that route on this build, looking at 24 inches, we would need 1.5 by 1.5 by 1/8 inch. And again, those wouldn't count as joint reinforcements, but it doesn't matter because we're using minimum 16 gauge unreinforced. And then this is a detail of what that third option would look like. So now we're going to look at an example building some spiral seam round duct. This is negative 10-inch, 24-inch diameter. And we're going to get into the spiral seam tables, which are table 3-10 through 3-13. And more specifically, we'll be looking at 3-13, which is for negative 10-inch water gauge. As you can see from this table, it looks identical to the longitudinal seam, and it's also kind of mimicking the rectangular tables that we looked at a few weeks back, giving us our minimum gauge, our minimum reinforcement requirement, with an A, B, C, all based off of your duct size and the stiffener or reinforcement spacing that you select. So spiral seam round solutions. So I'm not going to go through the whole thing, but the process is identical to the long seam. There's multiple solutions again, based off of unstiffened, no reinforcement, 12-foot, 6-foot, 8-foot, 2-foot reinforcement or stiffener spacings. Typically with spiral, you can fabricate, to desired field lengths, instead of just sending out a 10-foot stick, you can set the machine to cut 24, 36, 30, whatever round length joint you want. And then typically for spiral, lighter gauges are available based on using long seam construction. And then any fittings that are used for spiral duct systems, that are fabricated from longitudinal seam gauges, except when using the spiral seam body fitting elbows. And then those again would follow your spiral seam gauges. All right, a little bit of commentary on single wall round duct liner. So this you'll find in section 7.6 on page 7.16 of the standard. And round ducts using single wall kerfed rigid board insulation liners do not normally require pins, adhesive, or other types of mechanical securement in straight duct sections, but there are some exceptions. So if the insulation slides easily in the duct, if there's a loose fit, on vertical runs or other runs greater than 45 degrees from horizontal, where the vertical drop exceeds 16 feet, clips must be installed on every other liner section and finished with a row at the end section. In addition to the clips that we just discussed, so on vertical runs of 60-inch diameter or greater, you must have mechanical fasteners. When you have partial liner applications, anywhere you have single wall round duct and the liner ends, and the unlined metal continues, the downstream or last section of the liner must be mechanically secured. Negative pressure applications, obviously you're going to want to secure that liner. And then you're always going to want to follow the manufacturer's installation instructions as well. All right, so we've looked at longitudinal seam, spiral seam construction. Now, just briefly, we're going to look at aluminum construction for round. This is table 3-14. And here would be your equivalent aluminum gauges based on the duct diameter. So this table is a maximum of 2-inch water gauge positive pressure and 2-inch water gauge negative pressure. And you can see that, the negative pressure kind of taps out around 60 inches to 84 inches. And anywhere it says NA would be not applicable. There's no gauge available for that size and diameter. So anything outside of this table, you would want to go into the round industrial, and there is an aluminum section to build aluminum ductwork at higher gauges and larger diameters. All right, so we've got through our round duct construction options. Now we're going to check out some flat oval round duct. So the standard covers longitudinal seam positive pressure, and then spiral seam positive and negative pressure. Longitudinal seam minimum wall thicknesses would follow table 3-15 for the minimum gauges, and then that's going to be based off of the major dimension of that flat oval ductwork. And then longitudinal seam flat oval is reinforced like rectangular, and that reinforcement is going to be based on the flat span. So your flat span is equal to the major dimension minus the minor dimension. So if we had a 60 by 16 flat oval duct, you would do 60 minus 16, which gives us a 44-inch flat span. So that's what you're going to use to base your reinforcements on. And then any longitudinal seam fitting gauges would follow the longitudinal seam straight duct rules. So here we're just looking at a cut through of flat oval duct to kind of illustrate the major dimension, your minor dimension, and then your flat span. Like I mentioned, the standard also covers spiral seam, positive and negative pressure. So these construction tables, they're separate construction reinforcement tables, table 3-16 through 3-22. And then any fittings used in conjunction with the spiral seam flat oval duct, you would fabricate with 2 gauges thicker, which would be 1 gauge, 1 even gauge heavier than the duct, provided that the reinforcement size, type, and spacings are maintained. So sometimes working with really big elbows, there's sometimes a little bit of confusion on how to reinforce, but you would just maintain, say you pick a 4-foot reinforcement spacing, you're just going to follow, maintain that 4-foot reinforcement spacing throughout that entire fitting. So for longitudinal seam flat oval duct, here we're looking at table 3-15. So this is going to be your minimum gauge up to positive pressure 10-inch water gauge. And this is based off the major dimension, not the flat span, but the major dimension of the flat oval up. And as you can see, we have your longitudinal seam minimum duct gauge and the fitting minimum duct gauge associated with those major dimensions. So jumping into an example, building some longitudinal seam flat oval duct. For this example, we're going to be looking at 46 by 20 at positive 10-inch water gauge. We have our major dimension of 46, our minor of 20, and then our flat span is going to be 26 inches. So first step, we need to determine our minimum gauge, and that's going to take us to table 3-15. And again, for this table, we do follow the major dimension. It's based off the major dimension. Just throwing that up there again to reiterate our flat span. So jumping to table 3-15, based off of the major dimension we have, we're going to be looking at the 48-inch row, which gives us a longitudinal seam requirement of 18 gauge and a fitting gauge requirement of 18 as well. So now we know the minimum gauge. Next, we need to determine, what's our reinforcement requirements. And like I mentioned earlier, so this is going to be based off of the flat span of, for this particular example, is going to be 26-inch. So now we need to go to the correct rectangular duct construction table. We would pick our, select our reinforcement spacing. And then we would determine, which reinforcement class requirement we have based off of that flat span and the reinforcement spacing that we select. So for this example, we would follow the 10-inch water gauge construction table, and our flat span is again 26-inch. And then we have the option to pick from 8-foot reinforcement spacing down to 2-foot reinforcement spacing. And again, this table is simply telling us which reinforcement code we need to follow because we already selected the gauge from table 3-15. So if we were looking to build this duct, with 5-foot reinforcement spacings, we would need an H18. Well, the 18 we can ignore because we already had that gauge selected from the previous table. So we're going to look at either the H, or we can do a G class reinforcement while using or adding a tie rod. So for this particular one, the G reinforcement would be 1.5 inches by 1.5 inches by 1/8 inch angle. And then there's a couple of tie rod options. There's a type 1 or type 2, and these can be found on figure 3-7. Which here's that figure now. Type 1 would be an internal tie rod, and then type 2 would be an external tie rods. So now we're going to look at spiral seam flat oval duct. We checked out longitudinal seam. Now we can go into spiral seam. So we're going to use the same flat oval duct size for this one, 46 by 20. We're looking at 2-inch water gauge. Again, we have our major dimension, minor dimension, and flat span all equal to our previous example. But for this one, we need to make sure we go to the correct flat oval reinforcement table. So for that, we would be looking at table 3-18. This is going to be the spiral flat oval reinforcement table. And this is all based off your flat span. So for our example, we're still looking at a 26-inch flat span. And we have some options here. We can choose the unreinforced column, which would give us 18 gauge. There's a 12-foot reinforcement spacing. We have a 6-foot reinforcement spacing option, and then a 3-foot reinforcement spacing option. So if we were looking at the 6-foot reinforcement spacing option with this flat span, we're looking at an external reinforcement class of an E, minimum duct gauge of 22. And then there's also an option to add a tie rod, and that's telling us we would need 1 tie rod for this particular build. And that's option. So it's either you would follow the external reinforcement or the option of 1 internal tie rod. Both are not required. So following the spiral seam flat oval table, table 3-18, we would build the duct from 22 gauge. We reinforce the duct every 6 feet based off of our reinforcement spacing that we selected. And again, we would choose, not choose, the table chose it for us, but we would use the E-class external reinforcement, or optionally, we could use 1 tie rod. And then any fittings fabricated would be 20 gauge based on that 2 gauge rule, or 1 even gauge heavier for your fittings. So double wall round and flat oval, we went over rectangular flat oval in our last program. And again, so this is similar in construction to that rectangular double wall. The inner wall is typically attached, not typically attached to the outer. Primary function is to attenuate sound. And then you also still have the risk of through metal or condensation with double wall round and flat oval, similarly to rectangular. And just throwing that detail up here again for through metal concerns. All right, throwing up a couple double wall flat oval details. You're going to have your outer pressure shell, which is going to be your construction shell, and then you have your inner liner, same as rectangular double wall. Some fastening requirements. Here, your outer sleeve needs to be a minimum of 4-inch long. Inner sleeve is going to be a minimum of 6 inches. And then both the inner and outer sleeve would need to be the same gauge as your outer pressure shell. And then on the outer coupling, screws must be used at uniform intervals, 15-inch max along the circumference, and 3 screws minimum on 14-inch or less. And here we have a couple other duct joint options in the standard. Figure 8.2 for double wall round. That's going to be a drawband type on the outer pressure shell with an inner collar or inner sleeve coupling. And then you also have figure 8.10, which is a Vanstone option as well. And then there's a 4-inch minimum on that angle ring. And then obviously you also have your inner sleeve as well. And then this would require a minimum of 3/8 inch flange on the ductwork for that Vanstone connection. All right, so we've gotten through round, we've gotten through flat oval. Now we're going to get into a little bit of hangers and support systems. So some basic definitions of hanger components, your upper attachment, which is going to be the attachment up to the structure, your lower attachment, which would be between your hanger and your trapeze or ductwork. Then you have your hanger, which is the vertical section, which could be wire, rod, strap. And then your trapeze, which is your horizontal section, your angle, channel, and so forth. Here we have just the different options that are laid out within the standards. I'm not going to read through each and every one, but I do want to point out the big red text in the middle there. So this is an important one. Your allowable load on the upper attachment, which is going to be 1/4 of the failure load of that upper attachment. So that's kind of the main thing I want to point out with any upper attachments requirements to the structure. 1/4 of the failure loads.
And just a note for our California contractors, again, the flat bar concrete insert that's shown there in the upper left, we did test that in accordance with ASCE 7 requirements, and it did pass fully. So we do comply with the requirements of the ASCE 7 for inserts that you would use in projects in the state of California. We also tested, as Jeff is showing here now, the wire coil and also the 1-inch minimum double circle. We tested all those in accordance with ASCE 7 and they passed. We do have a technical resource bulletin that's posted up on our website under the technical services for that if you need to use that for discussions with the general contractor, the inspector, whatever it might be. But that information is available. The test results are there also.
Perfect. Thank you. All right. So now some hanger lower attachments. Left detail is going to be your hanger strap. And then there, 1 screw, 1 foot, a 1-inch minimum foot on your strap hanger with 1 screw at each foot. And screws may be omitted, if the hanger loops is a continuous loop underneath of your duct. Looking at some round hanger lower attachment options, wire is good up to 10-inch diameter. And this isn't wire that we're talking about like a gripple or anything like that. This is just thin, what do they call that? Shot wire.
Shot wire, yeah.
Yeah. So
It's not a
Everybody,
pre-stressed air.
yeah, everybody freaks out. This is not the pre-stressed aircraft cable. This is just a wire. So the next one over in the middle, up to 36-inch diameter. So this would require a single hanger strap and then a separate single band. You would want to, that band would be the same size as the hanger strap. And then over just to the right of the 36-inch diameter max, up to 24-inch diameter, you can have a single hanger strap and band. So one continuous strap around the duct that's good up to 24-inch diameter. Once you get into diameters that exceed 36-inch round, you're gonna have two hanger requirement, and that again is either going to be rod, wire, or strap. And then for this detail, we are showing double saddle strap, saddles top and bottom. That is not a requirement of the standard to have both of them, but if the duct does deform, then it's becoming out of round, you would look to add the top band. And then when you're using strap hangers, up to 16-inch max, that's kind of the max requirement for hanger strap, unless the foot of the strap is placed under the bottom of a reinforcement. So if that strap hanger happens to, if it does land on a duct reinforcement, you are permitted to go wider than that 60 inches. But it must be placed and attached to a external reinforcement on that ductwork. And here we have our cable hanging system. So for this, obviously we're going to note to follow the manufacturer's installation instructions. And you can visit the SMACNA Testing and Research Institute website for any that have been SMACNA verified as an acceptable alternative. But the most important thing to note for these is to follow the manufacturer's installation instructions.
Yeah, and you'll note that these are not permitted to be used in any area where you have moisture, such as a pool application. The devices just don't hold up in those situations. Also, when we're just talking about static ductwork, you want to make sure the locking mechanism is perpendicular as shown in the detail here. They have different styles for size of bracing. That would be different than what we're talking about here, which is just basically hanging static ductwork.
All right, moving on with hangers. So looking at our trapeze, this is going to be our horizontal trapeze, which can be angle, unistrut, channel. When using table 5-3, which we're going to get into and cover in a little bit. So this is for duct widths up to 96 inches. Your A dimension is going to be 6-inch max. Ducts greater than 96-inch wide, your A dimension is going to be 3-inch max. And if you have any situations where you're outside of this A dimension, then you would want to start looking into the rectangular industrial duct construction standard to start sizing these hangers or trapezes. Some rules for duct supports. So round duct supports are going to be every 12 foot or less. Rectangular duct supports, we're looking at every 10 feet or less. Again, upper attachment has an allowable load of 1/4 of the failure load. Horizontal ducts must be supported within 2 feet of each elbow and then within 4 feet of each branch. And here we have a couple of details. This is figure 5-12. This is a newer detail in the 4th edition, kind of detailing out that requirement, at elbows. What I will point out is, in the shaded section here, you would need at least one support within the shaded section. And then you can see there's an A and a B dimension. So A and B added together can't exceed the spacing from table 5-1 unless you add an optional heel support. And you can see that shaded section. Hopefully you can see my mouse kind of wiggling around on the screen there, is 24 inches on either side of that elbow. And then obviously you do not want the support spacings to go beyond the maximum per 5-1. Here's the next newer detail that was added in the current edition. And again, this one, same as the last one, you want at least one support within the shaded zone, and that's going to be 4 feet or 48 inches on either side of the branch or tap. And then you would not want to position a support directly opposite of the branch line. You would want to relocate that to the other side. And then any support, no supports required at the branch, directly off of the branch, unless the maximum support spacing on the main duct is exceeded due to the branch size. So if you have a super large branch and it's bigger than the support spacing that you're using, then you would need to go ahead and add a support on that branch within 1 foot of that main. All right, now we're looking at table 5-1. So this is your rectangular duct hanger minimum size. So this is all based off of the maximum half perimeter of the duct. And then you're going to look at either, your hanger sizing is based off of 10-foot spacing, 8 foot, 5 foot, or 4 foot. We have some single hanger maximum allowable loads. So for your strap, for instance, a 1x22 gauge is going to have a single strap maximum load of 260 pounds. And then a wire or 1/4 inch rod would be 270 pounds per single hanger. In that last little, or not last box, but the one that just came up, gives us some requirements when you have straps that need to be lap joined. We give you, like a 1x18 or 20 gauge or 22 gauge strap. If you have, it would require 2 number 10 or 1/4 inch bolt. And you would want to place the fasteners in series, not side by side. And this is actually something that came up, about a month ago?
Yeah.
Someone was getting called out on this. They had inserted, I believe, the deck, and I think their straps got cut. Or
Yeah.
somebody cut them.
Yep.
So there was a little bit hanging out of the deck, and they came in, followed this requirement, and they were getting called out on it. But we were able to help them, pointing them into this direction, that it is acceptable per the standard to lap the straps.
Jeff, there's a question in the chat.
The 10-foot support spacing, is that up to a certain square duct size?
Let's see.
The 10-foot to saw pop in.
So that would be up to a certain half perimeter of 168. So if we kind of go back, I'll just back it up a little bit. So here, is your half perimeter. We have the P divided by 2 gives us 168. So 10, up to 10-foot spacing, that we have options there. Above that, there would be no options in the standard unless special analysis was, taken for that, or we would go into the rectangular industrial. to be able to size that. So it's a combination of duct sizes, equaling that maximum half perimeter, if that makes sense, at the 10-foot spacing.
It does. Thank you.
Okay, great. And then one more thing to point out on this table. So the table does have an allowance for the duct weight, 1 pound a square foot insulation weight, and normal reinforcement and trapeze weight. So it's kind of some conservativeness is built into this table, but it does not include any external loads, such as snow, ice, wind, maintenance loading, or anything like that.
And if you wanted to add that in, that's possible. You have to go to the industrial standard, and the industrial standard does have calculations in there for maintenance load on the ductwork, or product in the ductwork, or snow load, ice load, wind load. It is available in the industrial standards. That's typically where we see maintenance load coming into play. But if you've got rooftop mounted ductwork, for example, in the Sierras or something, you've got massive amounts of snow you have to worry about, then we can definitely calculate what that ductwork would need to be sized to, as far as reinforcement spacing, gauging, and so forth. They handle that additional amount of snow.
Quarter plate.
Right. Yeah. Basically, all we do with the calculation is we take the wind, snow, or ice load, and we just calculate that into a pressure. And once we have a pressure, then we can do a lot with that per our standard.
Yep. Right. Sorry about that. All right, so now we're going to get into an example. We're going to size some supports. So for this one, we're going to look at single wall, 36 by 24, wrapped ductwork. We're going to pick a 8-foot interval spacing for our supports. Obviously, we are assuming the duct has been built correctly using the duct construction standard. So this would be based off of 22 gauge duct for that size. And then we would use table 5-1 on page 5.7. So jumping to 5-1, so we would find the half perimeter that worked for our duct sizing. So 36 by 24 gives us a half perimeter of 60 inches. So obviously it exceeds the 30-inch. So we would need to move up to that next category, or that next row, which is the P divided by 2 equals 72. We would slide over to our second column with our 8-foot hanger spacing. And it's telling us we're going to need a 1 by 20 gauge strap or a 1/4-inch rod for that. So our hanger solution, which is our vertical, is going to be a 1 by 20 gauge strap, or the 1/4-inch rod if you had to go with a trapeze. But most everybody's going to use 1 by a hanger strap for this type of application, for this size. Trapeze is not required. And then, the upper attachment, we would use a method that would support 1,280 pound tensile load. And this is the ultimate conservative method to size that upper attachment. Sorry, I got a little screen in my way here. So that solution would be a 1 by 20 gauge, and the max load for that single strap is 320 pounds. So this is where we get that 1,280 pound safety factor, is doing the 4-to-1, or the 1/4 the upper attachment. So that would be 320 times 4, and that gives us the 1,280 pounds. But in reality, the duct's going to weigh closer to maybe 125 pounds per 8-foot section. Speaking of hanger loads, this is detail that's out of the rectangular industrial, but I like to kind of throw that in here to give everybody, a sense of how you do calculate your load on the hanger. So it's actually half the distance to the next hanger for each hangar. So if it was equally spaced at 8 feet, obviously your 8-foot spacing, half of that would be 4. So your L divided by 2 one way, L divided by 2 the other way. It's going to be an 8-foot spacing. So your load would be based off of 8 foot of ductwork, 4 one way, 4 the other. And if it was unequal spacing, say, 10 on one and 4 on the other, well, then you would do 5 and 1. So your actual load would be 6 feet of ductwork versus, the 8 foot. So looking at a round duct hanger example 6 here, we have a 40-inch round. We're looking at 12-foot hanger spacing, no installation, and then we're going to look to use table 5-2 for this one. So jumping to 5-2, our minimum hanger size for round. So we would look at our 37 to 50-inch diameter range, since we're looking at 40-inch round. And it's telling us, this table is saying we need either 2 3/8-inch rods or 2 1-inch by 20 gauge straps. So our solution for this one, again, is 3/8 rod or 1 by 20 gauge straps. Or sorry, hold on. Yeah, that's right. We would use 3/8 rods, or you can also use 1 by 20 gauge strap if you'd like. And then for the band, you would either be as thick as the hanger straps or the duct. So when you're sizing your band gauge, if the duct ends up being 18 gauge, but your strap is 20 gauge, you would want to size that band 18 gauge for the duct work. And then wider is better for heavier loads to minimize localized buckling at that band. And then I noted earlier, it must keep the round shape. So 1/2 band may be used if the duct shape is maintained. So for trapeze selection, we would use table 5-3, and this is going to be on page 511 of the duct construction standards. There's some pretty important notes that you want to make sure you're following on that table. And then the design basis is shown on figure 5-6. So these are all the formulas that go into, that went into building table 5-3. So here we have table 5-3. This is our allowable loads in pounds for our trapeze bar. So this is based off of your actual trapeze length, not the duct width. And then we get into an example, which I'll, get into this table a little bit in more detail. And then there's also alternatives to use framing channel or strut. So these would be equivalent to, what's shown, like once you select a size from table 5-3, if it's telling you need a D trapeze size, you can come to this table 5-4 and you can size channel or strut that would be equivalent to that D. So if we looked at example 5, and then, which was 36 by 24, and we had 8-foot hanger spacing, and that was telling us, about 125 pounds per 8 foot for our ducts less than or up to 96 inches. We had that A dimension where, needed to be 6-inch max from each side of the duct. So we would come to size the trapeze on this table 5-3 using that 6 and 6 on either side. So that would actually give us a trapeze selection of 48 inches versus, the actual duct width of 36 inches. So it's important to understand, when using table 5-3, you're going to want to use the actual trapeze length versus, the duct width. So trapeze load calculations for any shape other than what's listed in table 5-3. Here's the load diagram. We always say just call SMACNA for assistance, and we'll walk you through that and see what the options are. Or we can go into the rectangular industrial to start, sizing hangars from there as well. And here's just some of the math that hurts my head. So here's your bending stress, your deflection formula, your shear stress formula. Again, call us so we don't have to, mess with any of these formulas. So now getting into supports from walls, we have a couple figures here. Figure A style and figure B. Figure A is with strap. We have a couple duct sizing options and band options. So 18 by 12, we'd say use 1.5 by 16 gauge. And then up to 24 by 12, we'd say, go ahead and use a 1 by 8 inch. And these brackets are sized for 12 foot of duct maximum. And then you would want to locate these up against the wall or a maximum of 2 inches off of the wall. Any application that's kind of out of these two parameters, we'd be looking into the rectangular industrial. Few things to point out for these supports on the walls. You can weld, bolt, or number 8 screw. And then deviation is permitted by other analysis. But what I did want to point out is your X and Y dimensions. So for X is going to be a 1 inch. Our Y dimension is going to be 2 inch. And then you're going to add any other attachment points to accommodate the load. So there's a minimum of 3 on 24 inch widen up. And then you're going to want to add these fasteners or attachment points along the side nearest to the anchors. So you only need one Y on I would say the outside, and then you would follow the X and the Y on the one closest to the anchor. And then here, kind of in the middle, we have the allowable load per fastener. So it's going to be based off your duct gauge. So a single fastener can handle 25-pound load on 28 and 26 gauge duct, 35-pound load for 24, 22, 20, and then a 50-pound load for 18 and 16 gauge duct. Here we're looking at riser supports from the floor. We have some suggested sizing for supports of 12 foot of duct, 36 by 18 up to 60 by 60. Anything, outside of that, you can size from table 5-3. And then this also follows this similar requirement, which is instead of an A dimension is now S. So for ducts up to 26 inch wide, that S dimension is going to be 6 inch max. For ducts up to and over 96 inch, anything over 96 inch would be a 3 inch max. And then you can select a pair of angles from table 5-3, each of which has the capacity of at least 50% of the duct weight being supported. Here we have some round support options, split band supports directly from the floor. There's some suggested split band support sizing and your bolt, excuse me, minimum bolt diameter. We give you some band sizing based on the diameters up to 12 inch, 36 to 24 inch, On the middle, split band support by supplemental angles or channel spanning a slab opening. Again, we give you some band sizing based on duct diameters and minimum gauge. And then for your fasteners, you know, we would go back to table 5-4 on 5.9. You know, the allowable load on that fastener is going to be based off of, you know, the duct gauge. And if we were looking to size, you know, the supplemental supports, this isn't something that you're going to do within the HVAC duct construction standards, but we can do that using the industrial duct construction standard. And I've got over the next couple slides, we have you know, how to go about doing that. So in the rectangular industrial, we have table 9-2. So this is for riser supplemental supports, and this is just all based on the load on that support and then the span of that support. So we're not worrying about an A dimension or anything like that, 6-inch max, 3-inch max. This is basically any span and the load, and you just kind of, and hopefully you can see my mouse. You kind of just do the math, you know, say it's 200 pounds times 12, you know, 6 feet, whatever that comes up to. You come to this P times LS max column, and you would find a number close to that, and that's going to give you your angle size. And I do get into an example, you know, using this and walking through how to use this table. And then there's also table 9-1, and this is going to be for channel, either figure A, which is, you know, laying flat, or figure B mode, which is when the channel's standing upright. And again, this is the same premise. You would use your load multiplied by the span of that channel to find your channel size. I think I'm going to.
Yeah, about 10 more minutes.
10 minutes, okay. But, all right, so, sorry?
If you want to look at the website, so.
Do we want to do that?
Yeah. Let's,
Skip this one?
yeah, let's skip this one and move into the.
Okay, so I did have another program or slides that I wanted to throw up. I thought I was going to get through this one a little bit faster, but I wanted to kind of get into the website, or the SMACNA website, and kind of how to navigate that and show kind of the offerings to members on there. So I will say, if you have questions on utilizing this type of support, supplemental support, you're gonna have my email, and just email me directly, and I can walk you through it anytime. So give me 1 second.
And these riser support details, we have to go to the industrial manual. That's usually with some pretty good sized ductwork. That's why we want you to give us a call, and we'll actually help you walk you through the calculations and kind of do them for you, since we've been around this corner lots of times with some of those large duct applications. So it's easier for us sometimes just to ask you some information. We'll run the calcs for you, give it to you, and then explain to you how we got to that solution. Then you can self-do it yourself afterwards. But we want to get to talking about some of the things that are available to SMACNA members on the tech side in our website. And we haven't done this for really anybody that I can recall the last year or two.
No, I started doing it about maybe one program ago.
Yeah, we want to kind of fill you in on what's going on out there as best we can, because sometimes the principals know about this stuff, but the project managers and senior people and foremen and so forth might not know. We'd like to make sure you have this information.
Yeah, we over the last year or so, we kind of started taking a poll of you know, when we're out on the road doing these types of programs in person, we're like, who's been on the website, who's seen our apps, and we don't normally get a lot of hands. So I kind of built this PowerPoint to sort of highlight everything that is available to members on the website. And here we go. So like this page, and you're going to get PDFs of this. This is just, obviously an overview of all the resources that are available, and maybe not even all of them. I'm probably missing some, but obviously our standards, manuals, guidelines. But more specifically, what's on the website is going to be our on-demand videos. We have web-based apps. There are phone apps. The technical inquiry form lives on the website. And so on. And those are the kind of things that I wanted to touch base on today, specific to the website. So for those that have not been on the website or have been, but maybe haven't spent a lot of time on it, kind of have like a little navigation slides here. So obviously, SMACNA.org is going to bring you to the landing page, the home page. We have technical standards, education events, business resources, government affairs, community news. There's some other links about the industry, specifically about SMACNA, the SMACNA calendar, chapter resources for chapter execs, SMACNA store, and SMACNA Connect. And then this is, kind of your login, where you would go to log in. And then, of course, we have a search feature, and I haven't even updated these slides. They're kind of new, but we also have the AI or artificial intelligence search option as well.
Jeff,
So, yes.
could you go over setting up a login? Because I believe that not everybody on this Zoom has access.
I got that next. Yep, jump into that. So this is just kind of the breadcrumbs, if you will, in each tab. I'm not going to go over all of them, but every one of these is a tab that sends you to something else, useful to you and your business. So here's the SMACNA member access and login. So what you would do is, come to the home landing page, go up to the login, upper right-hand corner. So now if you've logged in before and you have access, this is going to look familiar. This pops up. You can enter your credentials in and just hit continue. But, let's say you do not have credentials or you forgot your password, so you can come to this page, select forget password if you haven't logged in a long time. If you haven't logged in since we switched over to the new website, you're going to want to come back and do a forgot password. And then if you're just new to the site completely, you're going to select the join now option. And that's just going to walk you through, entering your email address, which needs to be associated with a SMACNA contractor address. So you wouldn't be able to use like your Gmail or personal. It needs to be, accompanied with a SMACNA contractor email address. If you have any issues or you don't know if you have access, you can email me, or you can email membership@smacna.org. Very attentive. You'll be responded to that day, unless it's like super late at night, and you can't fall asleep and you're wondering how to get on the website. But the next day you would get a response from membership at SMACNA if they needed any more information, to help you get into the website. So kind of walking through that again, you can go to the login tab on the home page, enter your credentials and continue if you have them. Select forgot password. You can join now, or email membership@smacna.org for your assistance. And I tell people this isn't a requirement, in the subject line, if you just put website login, the company name and your name, and hit send, you'll get a response. Right. So hopefully it was quick, but hopefully that helps, people that haven't either logged on or it's been a while since you've logged on.
I put a link in the chat that leads to a pretty helpful page there.
Oh, perfect. And again, you'll also get these, PDFs of these slides to kind of refresh. Yep. Also on the website, we have on-demand videos, and these are technical training videos that are, simply for our members. It's behind the login, so you would need, SMACNA login credentials to get to these videos. But we currently have 3 videos up on the website. And they're what, roughly 5-6 minutes each?
Yeah, roughly 5 to 6 minutes each for each one. So it's something you can watch and take in a bite.
Yeah. And the 3 videos, one video covers slip and drive selections. The next video would cover TDC, TDF duct construction options. And then the third video up here of what we're calling our HVAC duct series is going to be, covering tie rods, positive and negative pressure, sizing tie rods as well.
And the next 3 videos will be loading up, hopefully, let's say by mid-June will be 3 industrial videos. We just got the final draft of the last one in. We're just going through it to make sure it looks okay. If it does, we should have those 3 videos up between now and mid-June. So it'll be 3 industrial videos that we'll have up for industrial ductwork.
Yep. Another important one that I like to kind of go over is obviously our technical inquiry page, our technical inquiry form. This is going to be at, home technical standards, technical inquiries. This is, if you've never submitted one or submitted a question, this is what that page is going to look like, that form. It's going to ask you for a subject, your name. These are all required. Company is not a requirement, but if you are a SMACNA member, it's better. I always say, put your company in there. That way we can identify, and confirm membership, and address you properly. And then of course your email, phone number, and then there's are you a SMACNA member? Please put yes. We go through and check, to make sure, so please put yes. So those would be like the kind of 3, I don't want to say important ones, but make sure it's a company email, company name, company email. And then, there's some other things you can select. And then obviously, whichever document you're looking to get information on, a page, figure, any table, and then, your specific question. And then you just hit submit, done, and it magically appears in our inbox, and then we get back to you.
Yeah, and it's kind of critical that if you can put the phone number down also. We're a little bit old school here, and that we'll get your question, and 2 of us might look at it, and 2 of us could interpret it a different way. So sometimes we'll just call you up and say, okay, this is the way I'm interpreting your question. You might say, no, that's not what I'm looking for. I need this. Oh, okay, great. So sometimes a 30-second phone call with you will get you an answer a lot quicker than bouncing back and forth with emails, trying to interpret your sentence versus my sentence reply and so forth.
Yep, we will call you.
Yeah, happens quite often.
A couple things, for technical inquiries, obviously, to support our members. We're here to answer your questions and relate them back to the duct construction standards. Make sure if you have any questions on, am I building this right? Am I looking at this right? It's easy to just ask us the question before it gets into either fabrication or even installation. So we rather address it at that point than it getting too far in the process. And other good benefits of inquiries are, well, it helps, code officials, designers and members, to interpret the standards. And then also it's kind of a source of feedback, for manuals, for the updates. Like sometimes we'll get, hey, there's a mistake on this page from random people. And we're like, okay, save it, set it off to the side, get it on the next update. And if we're getting a lot of inquiries on a certain thing, it can be an early indication of, construction trends. Like we started getting a lot of large duct.
Right.
How do I build big duct? How do I do this? So, with large duct, so that kind of cued us into say, hey, maybe we need to do a large duct, portion of training, when we're out on the road. So this helps us, kind of help you guys, I guess. And then I think I got a couple minutes, about 4 minutes, which is perfect. So there's a ton of technical apps on the website. I'm not going to specifically go through each one, but we do have an air duct leakage app. We have a downspout and gutter sizing calculator, which is based on the architectural sheet metal manual. There is a ductulator, and I'm calling these apps. These are web-based. They are web-based, but if you see a little phone off to the side, that means that there is a phone app available for that web-based application as well. We also have an exhaust system design that can help you create exhaust designs using the constant velocity design method. Of course, we have our HVAC duct construction app, and then a rectangular industrial duct construction app, and a round industrial duct construction app up on the website. And you notice some of them had lock marks next to the titles, some did not. So the ones that are locked are obviously behind the member login and are only accessible to SMACNA members. And then, future apps, we're always kind of out, we're out on the road saying, hey, what do you guys see that, could help you as far as, having a web app or a phone app. So we're always trying to get that feedback to, better what offerings that we do have. And with that, we're not going to go check out actual apps.
Yeah.
This is my contact information, my email, and again, this will all be available, in PDF format as well within the next couple of days.
Great.
So
we'll wrap it up.
With that, I'll stop sharing.
If anyone has any questions, please go ahead and unmute yourself. Guys, we'll stick around for a few more minutes.
Yeah.
If necessary.
Oh, yes.
Of course.
Any questions?
Anyone?
Must have the Ferris fuel thing.
Yeah. Well, if it's something you don't want to ask out loud here or in the chat, but you do have a question, feel free to email.
Right.
And reach out to me directly.
Yeah, and we'll address it for you. Just send us a note.
Yeah.
Okay, thank you guys, and thanks for sharing the information about the website. We'll be sure to reiterate that to everyone. Getting lots of thank yous in the chat, so
yeah,
great.
Good.
Okay, well, thanks again, and we'll see you guys on June 24th or the 3rd, part 3.
Perfect.
Okay, thank you, everyone. Have a great day.
Hey, thanks, everybody. Thanks for setting this up again.
Yeah, you're welcome.
Thanks.
Bye.
Bye.
That's not working.